Hey, what's up? Okay, so in the last video we set up this problem, this truss, and now we're going to start solving it. I'm going to go a little bit faster in this video, but I'm still going to try to stay at a slow rate so that way I don't turn into Christo, because I really don't want to confuse people. And obviously if you're watching this, then Christo didn't, or rather he did confuse you if you're here watching this, I guess. So I am going to stay slow. I'm just going to move slightly faster, hopefully not significantly. So the first thing that we can do is we can say that, okay, we know that the vertical piece... okay, so first look at C, and you can see that this line right here is horizontal. So it's not pulling C up at all. But something has to be pulling C up with 5 units of force, and that's this AC diagonal. And what are the pieces of this AC diagonal? Well, there's that piece and that piece, right? And you can imagine this angle right here is that 37, right? Whoa, that's thick. Sorry. And that was probably really loud on your end too. But there's that 37-degree angle. It's that same angle. So how do we go about finding what AC is? Well, this is actually a decently simple problem, because we can figure is we have this side, we have opposite, we want to find hypotenuse. So how do we go about doing that? Well, sine of 37, or rather sine in general, is equal to opposite over hypotenuse, right? So if you multiply both sides times the hypotenuse, you get the opposite. So we have the opposite, right? We have what this opposite side is. So we know that the height times the sine is equal to 5, because 5 is this opposite. So the height is AC. Or, I'm sorry, not the height, the hypotenuse. We know the height. The height is 5. The hypotenuse is AC. Right, that's just this. So that times the sine of 37 equals 5. Get used to this right here, because if you can just kind of get it ingrained in your mind that the diagonal times sine gives you the height, and the diagonal times cosine gives you the length, you should never really have a problem, because the rest is just simple algebra. But so then if we plug in what we have for sine of 37, we get AC times I'm going to use the 0.6 times 0.6 equals 5. Then what happens when you divide 5 by 0.6? You get AC, right? Does that make sense? We're just dividing by the 0.6 right there. So we get 5 divided by 0.6, and that's equal to, handy dandy calculator, 5 over 0.6. I could have done that with a fraction, but I didn't feel like it. And we get 8.333, so I'm just going to write 8.33. That's about where Dr. Christo would probably truncate it. And there we go. We've solved one piece of our truss. So I'm going to go here. I'm going to change that to white just so I can steal the number there. And that is, we said AC, right? Okay, so that's AC. So we can get rid of all this. If you need to see it again, rewind the video, because I need the space. I like having the space clean, because I feel like it's less confusing for people. I feel like when the whiteboard or this blackboard is filled with numbers and symbols and all crap, I feel like it confuses people, so I don't do that. So we have AC. So what I'm going to do is I'm going to make the AC line white, nice and thick. And what's going on with AC? Well, if you think about it, this is being pushed down. C is being pushed down, so that means that A has to pull back up. So this is a tensive force. So basically what that means is that C is being pulled that way, A is being pulled that way. So it's actually kind of counterintuitive. This is the first video where I'm really paying attention to where the arrows are facing, but tensive is facing inwards, or rather towards each other. If you need help remembering that, I'm willing to bet anything that Lauren or Jacqueline made this up, but acronym is CAT with 2 T's. Whoops. And you can just think compression, away, tension, towards. So it's tension, so they're going towards each other. And remember, tension is just like as if it's being pulled. Compression is if it's being crushed, if it's being pushed together. So this is actually opposite what I do in most of my videos, but in most of the videos I was just trying to make it make sense. Now I'm trying to actually show you a final way of solving it. I don't think it's going to take off for arrows, though. I really don't. But just as a fact, tension inwards or tension towards, compression away, or compression outwards, away from the center. Okay, so what can we work on next? Well, let's see. How about this piece right here, this CD? Well, let's think about it. The AC is pulling on C somewhat in this direction, right? Since it's diagonal, some of its pull is going to be in this direction. So that means that CD has to push back, right? CD has to push back with the same amount of force, so that way A doesn't pull C. So D has to pull, or rather, D has to push back on C. I'm making a video. Sorry, Nicole. We'll have to wait till after the video. She can wait. Okay, so how do we go about solving this? Well, what's the horizontal portion of this AC? Well, this is just what I was trying to hopefully make clear to you, is that the hypotenuse times the sine gives us the opposite, and the hypotenuse times the cosine gives us the adjacent. And right here, if this is our angle, this is our adjacent, right? It's like our length. Our adjacent is kind of like our length, and our opposite is kind of like our height. We want our adjacent, so we are going to use this one. We're going to use the h times cosine is equal to a. So we get, what's our h? Our h is our hypotenuse, right? That's our AC. So we've got the 8.33, and that's equal to, times cosine of, well, cosine of 37 equals our adjacent. But what I'm actually going to do is, I'm wondering if I should go with fractions. Or, nah, it's fine. Okay, so we get 8.33 times cosine of 37. And what's our cosine of 37? That's 4/5, right? So times 4 or 5, or rather 0.5. Or, I'm sorry, 0.8, right? That's just what we put up here, our 0.8. And that's equal to, handy dandy calculator, well, that's the 8.3333. It's okay. I would recommend, actually, when you type stuff into your calculator, use 2 digits more than you would actually write down, just because that way you get the more accurate answers. So I'm going to use I would use like 8.33333, like a bunch of extra. Why not? Times 0.8, and we get 6.666666. Yay! Fun. 6.666. Just 3 sixes is fine. And that's equal to our adjacent, right? That's just that's the horizontal portion of this. That's how much AC is pulling. So that means that that's got to be how much DC is pushing back, right? Because that's the only force acting in the x direction. Hopefully that makes sense to you. So I'm going to kind of take that we just figured out, our CD or DC right there, and I'm going to fill it in our chart over here. So now I'm going to draw in our big white lines, and now think about CATT, compression away. And you figure this is a compressive force, right? Because actually here it would be better just to say kind of, if C is being pulled this way, like this arrow, if C is being pulled that way, it's gonna, D has to push it back with the same amount of force. And if D is pushing away on C, C is pushing away on D. So in that case, compression away, they're pushing away from each other. So that's where those arrows go. So we're getting closer. We're what, 1, 2, 3, 4, 5, 6, 7, 8. So we are 20% done, and we still have 5 minutes in this video. So actually, Yeah, I'm going to keep going in this video. I'm going to do AD. AD is really, 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 really easy. Because look at this. Look at D. Don't look at A, because it'll be misleading, because it'll make you think that something's going on that's not. Look at D. D is being pulled, or maybe pushed, we'll say pulled down with 7 units of force. So that means that A has to pull it back up with 7 units of force, because there is nothing else that could hold D up. So that one was really, really easy. So that one, super simple, 7. Right? AD is, or D is being pulled down with 7, so it has to be pulled up with 7. So that one was pretty simple. So we're going to draw our big blocky white line here to show us that we've finished this. And then, is this going to be pointing inwards or outwards? Well, think about it. We said that D is being pushed or pulled down, so A has to pull it back up, right? So pulling is like tension. You can think of maybe pulling on a line of like laundry clothes. It creates tension, makes it quite tense. So what's the next thing that we're going to do? Well, the next thing is going to be another part of D, another one that's actually extremely easy. You figure if D is pushing C away here with 6.66 units of force, right? Remember how we got this? We said that A is pulling on C, so D has to be pushing C away. How is D pushing C away? Well, that means that E has to be pushing D away, right? Because D has to be pushing off of something. So D is pushing C away, and it's pushing off of E. So, I hope that made sense. It's basically DE is counteracting DC. So we're going to draw our big blocky white line. Again, pushing. They're pushing each other. So pushing away. Think maybe like you're pushing Neil away because he's creeping on you. So it's pushing away from the center. And that was another really, really easy one that we just solved, because now we just go to CD. We said CD is 6.66. Okay, well, DE has to be pushing with that same amount, so that way D doesn't start moving. So that was a really easy one. Now that I've got, we're 40% done, and that's even including all the reactant forces, which some of them we'll find out I think are 0. But now I'm going to stop this video, and I'm going to probably finish the truss analysis in the next video, and I'm probably going to make a whole new video. I'll probably finish the truss analysis and start the torque. Maybe start a little bit of the torque in the next video. It might take another 2 or 3 parts actually, because I'm going to explain it in super duper detail, hopefully. But hopefully by then you'll kind of understand what's going on with the trusses. I've actually heard some good feedback that my videos are helping people, which made me feel kind of good. So let me know if this works. Let me know if anything particular that I'm saying does or doesn't make sense. If there's any particular topics or any particular things that are giving you challenges, I have no problem making a video. These things take 10 minutes out of my life. It's not a big deal for me. So just let me know. Okay, I'll make a new video soon, so I'll see you then.